I know I early voted, and it wasn't that difficult to do in Erie County because they had like almost 40 different places where you could. I know Niagara County only had two, so it was a little bit more of a challenge there. But I think because there's so many regular polling places as opposed to the limited number of early polling places, I'm hoping that lines aren't too long here. And all the doom and gloom you see on the news about election day, I don't think it's going to be that controversial in terms of intimidation at the polls in New York State. Let's hope not, anyways. Let's hope not anywhere. Um, okay, so let's see if I remember correctly. Something that I forgot to put on this list is that project 2 is due today. And so let's start with project 2. This morning, I woke up in a panic, and my alarm went off about all of the stuff that I had to grade. And amongst what I had to grade was project 2 was due yesterday for my Monday, Wednesday, Friday class. And so rather than going for a run, I just started grading at 5:30 this morning. And sadly, it didn't take me all that long to do it because a heck of a lot of people did not turn it in. So to circumvent that occurring, how are you guys doing with that project? Does anybody have questions about it?
Yeah, I
Okay,
do.
yes.
Um, the the loss. I don't remember how to get the loss. Is it the same for everything? Like how you had the 4.23?
No, let me go through people who are coming in late. Remind me at the end of class in terms of attendance. Let me go through to the lottery website. And let me go through and
Because I need to ask a question about the project too.
okay, I'll answer yours after I answer this one. You're fine. Thank you for making sure I made note of the fact. I'm going to just pick the first game because it's there. They don't give you the odds of losing. So what you need to do is I'm looking at this game, but again, you'll find the same type of information for every game. If the odds in favor of winning is 1 to 4.85, wouldn't the odds against winning be the reciprocal of that, 4.85 to 1? Remember when we had the odds for something to get the odds against it, we reverse them. With me so far?
So you just reverse it.
Yeah, and then if that's not winning, isn't not winning the same as losing?
Oh yeah.
So to find the odds of losing, take the odds of winning and just reverse it. The numbers are all pretty close, but they're not the same for every game. So for the odds of losing, reverse the odds of winning. And then for the probability of losing, remember that if odds are a ratio A to B, the probability of that event would be the first number over the sum of the two. So with this game, the probability that you lose is the first number, 4.85, over the sum of the two. And when I take 4.85 plus 1, I get 5.85. And so that's where that probability comes from. Better?
Is that like, did you add the 1 to that 5?
Yes, that came from taking the first number in the odds and putting it over the sum of the two number in the odds. It's the first number over the sum of the two numbers.
All right, and then I was confused about the table and the example and the content.
I have to apologize. The table in the example, when I went through to make a PDF from the website, it gave me that gibberish. So let's look at it.
Are they all the prizes or like?
Okay, so the, oh, I picked a long one. Over here, if I look at the prize amounts are what I call the outcomes. When I looked, I don't need this column. I don't need this column. Those are my outcomes for my values. What I have to do is take $1 away because I paid $1 for the ticket. And now over here, they gave me the odds of winning. I have to change the odds into a probability. And I'm going to cheat a little bit and go down to one that's a little bit easier to write. If this is my odds, A to B, it's the first number, 1, over the sum of the two numbers. 1 plus 250 would be 251. So this one above it, the first number over, when I add those two numbers, I'd have 503.44. And what you have to remember when you're looking at this table is that it never shows a column for losing. And so you have to create your own column. I'm sorry, not column, I apologize, your own row for losing. And my row for losing, the prize amount would be 0, the value would be -1, and the probability would be that number that we got up at the top.
All right, so you take the outcome, and then the second column you minus it by 1,
Mm-hmm.
and then the third column you just do the A over A plus B.
Right, and then in the final column, what you do is you take the value and multiply it by the probability.
Oh, so and then so there's going to be four columns or 3?
Right.
Or,
In expected value tables, we always had a column for the outcome, a column for the value, a column for the probability, and that last column I always named product. And the product was the value multiplied by the probability gave me the product.
so for that example, would you multiply the 503.49 times the 49?
No, you're going to take 49 and you're going to multiply it by 1 divided by 503.44 because that's a fraction. It's not that whole number. It's 1 over that. So if I take my calculator right now, in order to do that, I'll type in 49 times, and then to put that fraction in, I'm going to type in 1 divided by 503.44. When I put a fraction in my calculator, I put in the numerator divided by the denominator. And so for that one, I got something like 0.09733. And then
Seems a
for,
lot easier now going over it. I was a little confused looking at the table.
I apologize. I should have, instead of trying to create a PDF of this page, I was thinking about this when I was in a panic at 5:30 this morning. I should have taken a screenshot of this page instead. I'm very sorry that I didn't.
That's a,
Learning experience, because what happened was the state changed the website since last semester. And so I was not dealing well with the changes when I created that handout. I'm sorry.
One more question.
Okay, Chris, I was just going to go back to you and ask you if I answered all your questions. Go ahead.
Oh, for the scientific, like, you know where you have the on your example about the
Okay, so
first prize
uh-huh,
with the probability figure,
uh-huh.
is that a scientific like thing
It's
for the
scientific
calculation?
notation. So can I look at this example that's in front of us? I'm going to look at that one that I underlined in red. If I change that into a probability, that would be 1 divided by 494,401, remembering to add my 1, Oh, that one didn't go into scientific notation. I'll do the one above it. So instead, I'm going to look at this one. I'm going to take 1 divided by 1,2,3,6,0,0,1. And that one didn't go into scientific notation either. Okay, so I'm just losing here today. Is everybody all right if I clear what I've written on this table?
Yeah.
Okay. So then let me go back to Blackboard, and Blackboard, let me go to content. In content, let me, oh, this is so damn slow today. Let me go to projects. In projects, let me go to, you know, I'm sitting here gnashing my teeth that it's taking more than 1 second to get this up. And I have to just stop and think that, no, if I were searching through a folder for a single piece of paper, it would take me longer. So let me open this.
I just want to know if you just only write the 2 decimal, then you write E and write like the 10 to the power of, I don't know how to explain what I'm trying to say.
Okay, so you're looking at this entry.
Yeah. Yeah.
Okay, I'm perfectly fine if you only write something like that. What I would do though, when I'm filling in this table, once I've got this number in my calculator,
Mm-hmm.
before I fill in the rest of the table, because that number is in my calculator, I'm not going to clear it. I'm going to leave it in there, and then I'm going to just multiply it by the 499 to get this.
Oh, that's what you were saying. Okay, I
Right,
got you now.
because if you have to retype that in the calculator, it's a royal pain in the ass.
Yeah, that's what I was thinking too. I would have to like go over it and redo
No.
everything to
So
get
once you've
that
got your
number.
table set up, fill it in this way. You've got this ugly decimal. Rather than rewrite it, just multiply it. Just go with that in your display from having done your division. Go times
Okay.
499. And you don't have to worry about
Oh,
typing it in. If you
all
want,
right.
you could rewrite that as if it's times 10 to the negative second, 6, pardon me, it would be 5 zeros, 809. Right?
Okay.
No, 10 to the negative 6 meant I moved it 6 places.
Huh.
Okay? So if
Yeah.
when you're filling in the table, if you'd rather put in the decimal than the scientific notation, it looks something crazy like that. But again, once I've got this in my calculator, I'm not, there's no, I don't know if you noticed, I can do math, but I can't type. And so when I retype a number in my calculator, sometimes, especially if it's a crazy decimal like that, I miss a 0 or something like that. And so once I've got that answer, I'm going to just take it and multiply it by the 499. And when you look at your display, it says answer times 499. And it's because it's taking that last answer, which was that crazy decimal, and multiplying it by the 499. And I
Okay.
think if you go through it that way, it's a hell of a lot easier.
Okay.
Okay.
Thank you. That's all my questions.
I'm a little confused about the odds, like the 1. What does the 1 mean? That's what I'm confused about, where it says prize to the left.
Oh, and this is because I was a jerk. And I'm telling you that honestly. When I typed this in a spreadsheet, I typed one column for the first part of the odds and the second column for the second part of the odds. If you could read what was up here, they say that the odds are 1 in 1, 2, 3, 6, 0, 0. And so
Yeah.
I tried to type a separate column with a colon in to write that as 1, 1, 2, 3, 6.
I like the setting this way on the paper.
So, all right.
All right, so I don't have to worry about that column right there.
No, because when you were looking at the, can I clear what I've got written here so far, folks?
Yeah, that's fine.
When I look at the website, that 1 in whatever was this column that's called the odds. Okay, Zach?
All right, so So just to clarify, we're taking the prize amount and then minusing that by 1
to get the value.
and then multiplying it by the odds of winning for the,
But you're gonna take that odds and change it into a probability first.
Probability.
so we don't have to worry about the prize paid out.
No, we don't have to. You know what this is?
Alright.
This is just the lottery. Every day they update it and say, okay, of all of this scratch off ticket, people have won prizes already. They're saying 10 prizes were won already. And so there are 10 prizes left to be won. And so on a daily basis, if you want to see, hey, should I buy this ticket? Besides knowing the expected value, you could go to this site and they might say, okay, there's still tickets out there, but there are none of the big prizes left.
But
And so they're just for people who really like to gamble a lot. They're just kind of showing them how many prizes have been won already and how many prizes remain.
wouldn't that change the odds of winning because you have less?
No, because
less-
the odds of winning are based on the total number of tickets at the beginning.
Okay,
And I know what who just asked that question? I apologize. I didn't see your name.
Lucas, me.
Lucas, because you know what? When I saw this new table and I saw that the state had changed it, my head started hurting because I got thinking, oh my God, does that mean that the odds are changing on a daily basis, which is going to make this project obsolete? But somewhere in the fine print, they tell you that the odds column was figured out based off of the total number of tickets that were made.
Okay,
Okay. So yes, I know exactly what you're thinking. And I thought the same way when I saw this new table, but I double checked it. Okay.
okay.
All right. So are all project questions clear?
Sorry, I have one question.
Don't apologize. I love that you're asking questions. Go ahead, Janae.
So for the loss, is it just like one like loss thing, or do you have to do a loss for each prize amount?
No, there's one
Mhm.
thing for the entire game. And
Okay.
so for the entire game, I would add a column loss.
Yeah,
Prize is 0, so the value would be -1. And
yeah,
again, the probability of that would come from taking that overall odds of winning and change it into overall odds against winning.
yeah.
Okay,
Okay. Yeah.
anything else?
No, to the homework.
Okay, all right. Well, you know what? Let's go back to the notes for the day because that was where I was going to go.
Mhm.
Next, homework 14 is due today. There's questions on that homework 14. Or is it on homework 15?
No, homework 14. The first question was like, I was just browsing through and like, I think I can do pretty good with, because I haven't really started yet with
Okay.
everything, but the first question was kind of confusing to me. I don't know why.
Question 1.
Yeah.
Okay, let's see what it looks like when I open it. 50 million out of 94 million households watched the last episode of the popular television show. What percentage of the households were not watching the show? Okay. This actually reverts back more to what we did with probability. If I wanted to find
Oh,
percent watching, to find the percent that did watch, wouldn't that be my fraction 50 out of 94? I could write the word millions at the end. I could fill in all the zeros, but because they're both millions, I don't need to do that. So I'm going to take 50 divided by 94, and it's going to give me a decimal 0.5319. That would be 53.19 to the nearest tenth, 53.2% watch. And so if 53.2% did watch the show, how many did not watch the show? Wouldn't that be everybody else? Or 100% minus the 53.2, which would give me 46.8%. Does that make sense, Chris? Better? I'm being greeted by silence. Can you guys still hear me?
Yes,
My
okay.
thing was on mute, sorry.
Okay, all right. I got scared from when I don't get any answer at all. The first thing that goes through my mind is, oh my God, did I just totally confuse them? And then the second thing
Oh,
in my mind is, oh my God, is my internet down? And did I just physically move the entire class? And so when I
the
get
whole,
greeted by total silence, I'm not gonna lie, I'm prone.
no, the whole time I was here responding. Thank you very much. I get it now. And then I look up and see I was muted.
Okay, all right. Yeah, hey, you know what? I know that that's cumbersome, but thank you very much for muting yourself while you weren't talking, because otherwise we get an echo and feedback and traffic and dogs and television and everything else. So thank you.
Okay, thanks.
All right, anything else from this homework that anybody's wondering about? Okay, then back to my list of important things. This quiz here is due by the end of the day tomorrow. It's on organizing data. Up. It's in my math lab. It's called Organizing Data Quiz. You have to put your work in a folder in the quiz section of Blackboard. And it's on a lot of the content from homework 14. It asks you to do things like make a frequency distribution. It asks you to do things like make a stem and leaf diagram. It asks you about classes and limits for a frequency distribution. And I do believe it asks you to look at a histogram. So it's on all of those graphic displays that we used to organize them.
Professor,
Yep.
would you be so kind? I know I asked you over the weekend to help with one of those like class diagrams in homework 14. Could you just go over it in class one more time?
Sure. I gotta remember where the homework went. Can you remember the question number at all?
Hold on.
I could go back also and look through my emails and see if
Yeah,
I.
that's what I'm doing right now. Let's see. It was question 12.132. That's what it said. That doesn't make sense.
Yeah, I know what it means.
Okay.
12.132 is over here at 12.19. And so it's
Okay.
a little bit further back. We look at 5. Oh, 12.931, I'm almost there. 12.132 is the stem and leaf diagram.
Yes, yeah. So I get the stem and leaf diagrams,
Uh-huh.
but when it's like, what's going on with my mouse? When it's like this with all the all this, that's when I'm like, whoa.
Okay, when you look at this stem and leaf diagram, this is a back-to-back stem and leaf diagram, and what
Right.
they're doing is they're putting two together. So on the right side are the actresses, on the left side are the actors.
Okay.
If I took this stem and leaf diagram I'm going to do something that the question doesn't ask us to do, but I want to do it to make sure that you're clear on what it means. If I look at the actresses, are you all right reading their ages? The first would be 20, then the next one would be 21, then 24, then 26. And do you see where these numbers are coming from this table?
Hold on, let me move you. So, okay, so 20,
21, 24, 26, there'd be a second 26, and then there'd be a 27.
okay.
And then it would be 30, 30, 31, 31, 33, and so on. And
Okay.
oh, I'm playing with my pens today. So if the actresses are in red, we'll do the actors in blue. And so do you notice with the actors, there's none in the 20s? And if I were to fill out the actors, wouldn't it be 30? The first one's 30, then the next two are 32. And you see how I'm generating their ages from this list?
So they go backwards?
Yeah, because they're in order off of the stem.
That's confusing.
Well,
Don't you
if you wanted to, you could go in the other direction and say it's 39, 38, 37, 35,
Okay,
and you'd get that same list. But
okay, I see
when
now
make
how
the
you,
list,
okay,
The youngest guy is 30.
all right.
And was that enough to clarify all of the rest of the parts of this question, or do you want to go through it more?
I understand that now. Now the other one, I think it was one before this,
Okay.
where it's the classes where they give you, for some reason, I got really confused on that one.
Okay, so let's look at the question before this. Okay, a random sample. of-
No, not that one, the other, another one. Nope. No, that one I get.
Histograms you're okay with?
No, it was, I'll tell you in a second. I have it because I emailed you that one too. It was question 12.1.9.
I think that was the first question we had open way at the beginning.
Yes, these ones, for some reason, I get confused.
Okay, when I look at this, when I look at a table for a frequency distribution where they're grouped, whatever the smallest number is, this would be my first class, this would be my second class, this would be my third, and so on. When I
So
look
it starts at the top and goes down.
well, it could be the reverse. Yeah, usually it starts at the top and goes down.
Okay,
It would be the one with the lowest numbers, and usually. In each of the classes, the first number, I didn't do a good job pointing to that. In each of the classes, the first number is the lower limit,
okay,
and in each of the classes, the second number is the upper limit.
okay, first number
The
is,
smaller number is the lower limit, the bigger number is the upper limit.
and then the bigger number is the what? I'm sorry.
Upper limit.
Larger number is the upper limit. Okay. And what, this chart is called what again?
This is called a grouped frequency distribution.
Group frequency distribution. Okay.
And so my sixth class, let's see, 1, 2, 3, 4, 5, 6. This would be my sixth class. And you see that the lower limit, the smallest number in the sixth class would be 70.
Okay.
That was it.
All right. I guess I think when I was doing it, I was starting at the bottom and going up, and I just,
Okay, they're in order from top to bottom.
okay.
All right, great. Anybody else have more questions? If not,
I have one, Professor.
sure.
If we ever need to leave class early, what do we do?
You just leave class early.
Okay. Is it okay if I leave class?
The call didn't go well?
No.
Okay, the class will be recorded. Get what you missed from the recording, okay?
Perfect. Thank you
All
so
right,
much.
good luck. May the
Thank you.
force be with you.
I appreciate it. Bye.
Okay, have a good rest of your day. Go vote. So then, we talked about the project. Homework 15 is on our measure for central tendency. Which
Is
we
the
should-
quiz time?
Yes, it is timed.
Oh.
I have to apologize. I don't remember how much time I put on it. Give me a minute. I can look it up. Or are you all right with just knowing that it's time?
I'm alright.
You're all right. Okay. And I apologize. Part of me hates putting a time limit on quizzes, but call me a cynical old lady. Last spring, when we went to fully online, in all of my classes, I did not put time limits on things to start. And what happened was because people had an infinite amount of time in which to do something, they cheated like math. Every question, they took the time to use an app or software to look up how to do a problem. And so it wasn't, the grade was not a reflection on how much math they knew, but rather a reflection on how good they were looking things up online. I know it's kind of hard to pin down that level of cheating, but when I had somebody in a foundations math class give me an explanation instead of showing their work that involved calculus, I knew that they were cheating. And I knew that it was partially my fault because I gave them an infinite amount of time in which to do it. And so that's why I put time limits on, because I don't want to have a quiz grade based on how good you can look things up. I want a quiz grade based on how well you know the math. And so there's a fine line between too much time, that still gives people time to look things up, and too little time, which means you can't finish. If you notice you're running out of time, what you can always do is, write the questions down on your paper and finish them pencil and paper and submit them with your work. I won't give you quite full credit, but I will give you some credit for those. Okay? And I know the explanation isn't fair to a lot of you people, because I know most of you people would not cheat and would not look things up. But I can't make rules that are effective for part of the class and not another part of the class. And it breaks my heart, but it's kind of one of those things where cheaters ruin it for everybody. So, okay. All right. Now I sound like an old lady. I'm preaching at you guys. Sorry about that.
No, it's totally okay.
Right.
Yeah. So let's go through and let's look at after central tendency. And I guess we'll do a 30-second review of central tendency first. Central tendency was ways to describe the middle. And actually, before I get carried on, we did spend a lot of time answering questions on projects and homeworks, and I know a lot of people had submitted them already, but it's my opinion that if one person in the room has a question, everybody, there has to be other people in the room that are asking the same questions. So I think it's for the greater good to spend that time answering questions. Those of you who didn't ask questions, you were okay with the amount of time that we spent answering questions, yes?
Yeah, totally.
Okay. All right. So again, back on track. Describing central tendency, descriptions of the middle. I'll give you all a hint. They're all words. Can anybody remember what my 4 M's are? Can anybody tell me one of them?
Median?
Median. What is that?
Me.
Mean.
With it.
One more.
Mid-range.
Mid-range. Beautiful. And just quick description on how to find each of them. Median is the physical, oh, what happened there? The physical middle value. And we had to put them in order and find the middle. And we also, if we didn't want to count in from the ends, had that formula for the position of the median, which was number of values plus 1/2. And I apologize, I was on a roll. I did the talking and I want you guys to. So can somebody else help me remember how to find the mean?
Add all the numbers together,
Add up all the values and then what?
divide by how many numbers there are.
Divide by how many? So it's the sum of the values divided by the number of values. And instead of number of values, sometimes you see it written as sample size. Somebody want to tell me how to find the mode? Or what the mode is?
The number that has the most.
Most frequent. And remember, sometimes you can have more than one, and sometimes you don't have any. And then, can anybody else remember what the mid-range was?
I think that's the highest value in the set, and you add that to the lowest value in the set, and then you take that sum and divide it by 2.
Perfect. High plus low over 2. That was an excellent explanation. Everybody did good. Is everybody comfortable with all of those? That's what that next homework,
Can you leave this here for a second so I can write it?
yeah, I just wanted to scroll up to make sure I did it live. That was what homework 15 is about. That's the assignment that's next class. And so we're real good at looking at the middle of the data set. A lot of times people are considered with that middle. Of all the employees at my job, what's the middle salary? Of all of the people on the baseball team, what's the average batting average? If I look at, of all of the things that I sell in my store, what's the average size? I want to buy more of the average size. But can I get through life just focusing on the middle? Or can I scroll up yet? Can I move yet?
Yes,
Um,
sorry.
Sometimes we also want to know about the, it's called measures of dispersion. Or measures of the spread of the data. And to show why it's important to look at the spread of the data, I want to give you 4 data sets. And we'll probably be using these 4 data sets for the rest of class today. And we'll also we might be using it a little bit at the beginning of next class. And so what I want to look at are the exam grades for 4 students. Before anybody goes through and says that I'm violating privacy rules, I made these up. And so my 4 students, I'm giving them crazy names. First student, I'm going to call student A. And student A's grades on the 5 exams were 80, 83, 87, 85, and 90. Student B had grades of, and I'm leaving room to the right for a reason, grades of 75, 70, 85, 100, 95. Student C had grades of 100, 60, 85, 85, and 95. And student D at grades of 100, 100, 100, 100, and 25. So switch roles with me for a minute. You guys are the teacher. You have these 4 students in class and those are their test grades. Do you think those students are all the same?
No.
No.
No, it doesn't look it at all. What I'd like to do in this space to the side is I'd like to take a minute and ask everybody to please find for me the mean or the average for each of those students. I'm only going to look at the mean because usually when we grade, we only look at that physical average, right? When I grade, I want to include all of the tests. And so when I'm putting together your final average, I look at that average. So everybody please take a minute and find the mean for each of them. How's it going?
Almost done.
Okay. And then afterwards, I just remembered one more thing that I wanted to talk to you guys as a whole about. Get too much further in the content, and it has absolutely nothing to do with the content, but the thought of taking student averages made me think of it. But first, let's find out, what are these guys' averages?
85.
So student A has an average of 85. How about student B?
85.
How about student C?
85. I think they all have 85.
The
No,
last one is 65. I think. Maybe I
Yeah,
got
the last one is 65.
Did you get that they had 400s?
1, 2, 3, 4. 1, 2.
Oh, I had 300s.
Yeah, I could tell from the number you came up with. Okay, and here, I apologize. I'm going to pause for a minute and talk about something totally unrelated to this problem, and I apologize. As I was thinking about averages, I thought yesterday I got an email from Starfish telling me that I was supposed to complete something and make a comment for every student on where they stood in class. And my choices were super duper, you're doing well, your grades are low and I'm a little worried, there's no way in hell you can pass, drop the course, change to pass fail. I don't want to make that option change to pass fail for anybody because that's your decision. And that decision doesn't need to be based solely on what your grade is in my class, but how important this class is to your major. So I didn't pick that for anybody. The only people that I picked, your grades are so bad, there's no way in hell you're going to pass this class, are people who have not been in class for more than a month because they're, there's no way they've missed 2 tests. There were some people whose averages were super low. Some people hit averages, in the 30s and 40s. But in my mind, while it's really, really difficult at this stage of the game, there is still the possibility of passing because we have 5 tests and the 4 tests in the final counts twice, 6 grades. I dropped the lowest. And we've only gotten 2 of those test grades so far. And one of them is going to be dropped. And so even if your average is super duper low, if you work your tail end off, you can still pass. And so I wasn't going to tell anybody that has been participating all along that there's no way in hell they're going to pass. And so I did those strictly looking at the averages in Blackboard. I didn't look at attendance. I didn't look at any more detail. I hope I didn't offend anybody with what I put into that survey, but also I just want to let you know some folks have low averages, and I wasn't going to say that you had a withdrawal. but it's up to you how hard you're going to get. I've also received emails, not from this class, but from other classes asking me, can they do extra credit to raise their grade? My theory on extra credit, if I give an extra credit project, in order to count as extra credit, it has to be challenging. It has to be something above and beyond the course work. And in my mind, if somebody wants an extra credit project because their grades aren't good, asking them to do something super duper hard in addition to keeping up with the work is not doing them any favors. So my response is to anybody who asks for extra credit, I don't think you need to do your time doing something above and beyond the coursework that's hard. I think you're better off, you're more likely to raise your average if you really put that extra time to work harder on what we're doing to make sure that all of your grades from this point on are. Okay, I apologize, I meant to say that at the beginning of class, but I totally forgot. So
It's okay.
on that, and you, I think from the responses that I got from student emails yesterday, I'm guessing that those Starfish survey comments got sent to you. And again, I apologize. I tried to go through them quickly because I'm teaching 6 classes this semester and I didn't want to forget to do the survey.
You're doing a good job.
So, all right. But do you notice here, these students, they all have the same average, but they're not the same. And so in addition to knowing how the middle of my data set is, it's useful to know, well, how spread out are the grades? And so the first measure of dispersion is the range. Please notice, this is plain old range. Range is very different than mid-range. The mid at the beginning of mid-range tells me it's a description of the middle. Range is very much different. It's the difference between the highest and lowest values. So the range is the highest minus the lowest, reflecting on the fact that I can't spell, folks. And so over here, I'm going to make another column, and I'm going to call it the range. And so let's see, student A, their best grade was 90. The worst grade was 80. 90 minus 80 would give me a range of 10. So their grades are all pretty close together, yeah? How about student B? Their best grade is 100. Their worst is 70. So does everybody see their range would be 30? There's more spread there, isn't there? How about student C? What would their range be?
100 minus 60.
Which would be?
40.
Beautiful. And how about student D?
100 minus 25, which would be 75.
Wow. And so do you see how A is pretty consistent and D looks like they're in some ways all over the place? Or maybe that one grade was just very much out of character. So is everybody all right with this idea of range?
Yeah.
Tells me something. But there are other measures that statisticians use more than just the range that we'll find later in the next week. They give us a lot more details about the data set. Another one we're going to look at is the deviation from the mean. And deviation is a fancy word for difference. And so for each data value, we can find its difference from the mean. So if X sub n is the data value and X bar is the mean. This would be my deviation. So X event is a data value. And X bar, again, is the mean. So rather than bouncing up and down, student A, their data values were 80. I'm leaving a little bit of a space for a reason. 83, 87, 85, and 90. And so for each of them, I can find a deviation. Remembering that we said that their mean was 85. And so here, 80 minus 85 would give me -5 by deviation. 83 minus 85 would give me a deviation of -2. 87 minus 85 would give me a deviation of 2. 85 minus 85 would give me a deviation of 0. 90 minus 85 would give me a deviation of 5. And so that this column here would be my deviations. And we can say, okay, so some of their grades were above the mean. Some of their grades were below the mean. They were all identical.
I do have a question. I'm
Sure.
sorry. So why for like the 80 minus 85 and 83 minus 85?
Yeah.
It's like, is that like a -5?
Yeah.
-2?
Yes.
So why are those ones negative but the other ones aren't?
Debbie, can I first tell the class that I did not pay you to ask that question? The very next thing I was going to talk about.
Okay.
You're awesome. You're thinking ahead to where I'm going next. I love it. Do you
Okay.
notice that if these two are negative, when that deviation is negative, doesn't it tell me that the grade was below the mean? If the deviation is -5, it means that score was 5 points below the mean. Instead, if the deviations are positive, it tells me that the grade was above the mean. And so if you're looking at a data value that's lower than average, below average, the deviation will be negative. And that kind of makes sense because negatives are below. And if you're looking at deviation for a value that's above the mean, if the value is above the mean, the deviation will be positive. Better?
No. I'm
No?
sorry. Okay, so the 80 minus 85, it's -5.
Beautiful.
I don't know how to explain where I'm.
I think I know what she means. She's trying to say, why isn't it like 85 minus 80?
Because it's always, the formula is always the value minus the mean.
So
You could think that, I'm sorry to interrupt.
No, it's okay.
You could think of it this way. The way I think of it is if you want to try to find the standard deviation of any single item, start with the item. Always start with the item. So if I want to try the standard deviation of 80, for example, which is a single item in the set, I start with 80 and then I subtract the mean. It feels like it doesn't make sense sometimes, but if I start with the item, I'm telling myself I'm trying to find the standard deviation of that item. Does that make
Right.
sense?
Okay.
Better?
Okay. Yeah, thank you.
Yeah, no problem.
So again, each deviation is always, you start with the value and subtract the mean. Thank you. Only problem I have with your reasoning is is that we didn't use the word standard yet. Now we're going to add that idea of standard deviation. And I think in order to get to that idea of standard deviation, I want to change the page because otherwise the whole class is going to be on one long run-on page. Is everybody all right if I turn the page?
Yeah.
So when I look at that standard deviation, it's a measure of, on average, how far are the data values from the mean? I kind of liken it to a kind of average of the deviations. And I'm going to add that word kind of on front. Average of the deviations. We're going to see in order to find the standard deviation, there's a very long, drawn out formula, and we'll look at that last. There are different ways of finding the standard deviation. My favorite way, and it's not mandatory, but to find a standard deviation, unless I'm using software to do so, I like to make a table. And so let's go back and let's make a standard deviation for student A. Before we do it, usually a lowercase s is used to represent the sample standard deviation. In the first column, I put my data values. My data values I refer to as X sub n, which is that notation that we've been using all along. And so their test grades are 80, 83, 87, 85, and 90. I total that to find the mean. And so that added up to 425. And so my mean was that total divided by the number of values. 425 divided by 5 is 85. And I know we did that work already, but I want to recreate it because for your next example, you might not, that might not be done for you already. Then I make an optional column. How do you spell optional? O-P-T-I-O-N-A-L column with just the mean in it. Now, this column is not necessary, but I've been teaching math a really long time, and I find that if this column is in there, students are less likely to make a careless mistake. So you don't have to put this in there, but again, I find students, it benefits students to put it in there. So my mean is 85. Then for the next column, put my deviations, which would be x sub n minus x bar. And Debbie, going back to the question you had about why some of them were negative, I think if you put that mean column in there, you're always going to just subtract across. X sub
Okay,
n
that helps. That makes sense.
80 minus 85 is negative 5. 83 minus 85 is negative 2. 87 minus 85 is 2. This difference is 0. This difference is 5. And so those are my deviations. And I think when I set up my table, if I put that column in there with the averages, I would think subtract across. Now, this table, because it's the first time we're making them, we're filling it in up and down. But I think that for most folks, it's easier to fill in this table sideways. But I do want to fill it up and down for a reason. If I look at the total of the deviations, because we said we want to take average of the deviations, right? And in order to take an average of those values, I'd have to add them. And so please tell me, when you add that column, keeping into account that some of the numbers are negative and some of the numbers are positive, what do you get?
0.
0. Why does that column add to 0? Doesn't it make sense? Because if 85 is the middle value, shouldn't there be as much above 85 as it is below 85? Shouldn't the positives and negatives cancel each other out? That column will always add to 0 or approximately 0 if we round it to find the mean.
So the total of all deviations should always be 0 or close to 0?
Right. And the only time it wouldn't be 0 is, let's say instead my average was 85.1234 and I rounded to 85 because I rounded off. Then it won't quite be exactly 0, but it'll be pretty darn close to 0. And so if I take the average and they add to 0, it tells me that the average is 0, and that's kind of not at all useful. And so what makes it add to 0 is because some are positive and some are negative. And so we have to do something to overcome the fact that some are positive and some are negative. And so what we do next, the next column, what we do is we square the deviations. Okay, why would I square the deviations? Oh, wait, before I go on a rant again, we're taking x sub n minus x bar, my deviations, and squaring them. So that's what this heading is going to be, parentheses x sub n minus x bar, quantity squared. Okay, arithmetic. When I square -5, that means -5 times -5. When I multiply a negative by itself, isn't the product of two negatives positive? And so wouldn't that give me positive 25? -2 times -2 would be positive 4. 2 times 2 would be 4. 0 times 0 is 0. 5 times 5 is 25. That column, those values, oh, I didn't want to write that right underneath it. That column should always be positive. Always all positive. I guess I'm cheating there. It's not positive. It's positive or 0, right? 0 isn't really considered a positive number. Technically, I should say that those numbers are never negative, right? They're all non-negative. Be careful. Sometimes if you don't type it in your calculator right, You might get a negative when you square it if you don't put parentheses around that number before you square it. So please, please, please remember, the only reason we're squaring these is to get positive numbers. Every number that goes into this column should be positive. Now, backtracking a little bit. Once I have my mean, normally if I were doing this on my own, I would fill it in sideways. I'd go 80 minus 85 equals, I'd get my answer -5. And then I just hit that squared button. And if I just hit that squared button, answer squared, it would give me the 25. So I normally fill this column in going sideways. Does that make sense? So the next thing we want to do is we want to total the squares. So when I add that column up, I get 58. Now here's something that you have to remember. In this class, Mr. Blitzer is only looking at the formula for a sample, not a population. If we were trying to find the standard deviation for populations, think populations are big groups. I would not want to make this table for thousands of numbers. I think back in the Stone Ages, when I was in college and taking a math for education majors, we spent a lot of time doing standard deviations, and we were supposed to find the standard deviation for scores for like the equivalent of a class of students. And doing this for a table of 30 numbers was beyond tedious, doing it by hand. We don't want to work with groups that large. And because we're using the sample deviation, since we're using the sample formula, what we do is we divide the sum of the squares by, and I'm going to put this in color. Oh no, wrong thing, sorry. By 1 less than the number of values. Or n minus 1. This will be always one number smaller than what we divided by for the mean. And so we're going to take that, the number of values we said was 5. So 1 less than that is 4. So we're going to take that 58 and divide it by 4. And so when I take 58 and divide it by 4, I get 14.5. It's always going to be one smaller. The reason it's one smaller, if you go on to take a statistics class, has something to do with the degrees of freedom and the fact that because we're doing this for a sample and not an entire population, we're not as accurate. And so we've got to adjust for it. This is called variance, which is symbolized by S squared. So I would say that for this table, my variance, which is S squared, is 14.5. So we're saying that our estimate for the average of those values is of difference from the middle is 14.5. Doesn't that number 14.5 look very large for a measure of these deviations? They went from 5 to -5. What the hell am I doing with a number as big as 14.5? Well, what made the numbers big was when I squared them, right? And so doesn't it make sense that I have to undo that squaring process? So my final step is that my standard deviation which is referred to as S, is the square root of the variance. So my standard deviation, I'm going to abbreviate as S, is the square root of that number I got dividing. So when I take the square root of that 14.5, I get to the nearest tenth 3.8.
How do you do that?
On your calculator?
Yeah.
If I look at, do you have a calculator similar to mine?
Yes.
Okay, if I look at my calculator, as you're looking at the left-hand column, there's a button for x squared. Above the x squared button, in a different color, do you see a square root symbol?
Yes.
So what you have to do to get to that square root symbol is you have to press the pretty colored second button.
Okay.
So second x squared. Then I'm going to type in my 14.8. I'm sorry, no, I'm not. I'm going to type in my 14.5. It would help if I remembered the number correctly. I'm going to go second x squared 14.5, and it gives it to me. I think on most brands of calculator, the square root symbol is the second function to the x squared button.
Okay, thank you.
I know there were some people that had in the past for this class had a very, very basic calculator. And that was where the problem arose, because some of those basic calculators do not allow you to take a square root. Some do, but some don't. And so my standard deviation is 3.8.
For the I know we're not on that anymore, but for the variance, is that a 5/2 or is that a S?
Where I don't see where I have something over 2.
Where it says this is called a variance, and it says like, is that a S or a 5?
It's an S.
Okay.
Variance is always referred to as S squared. The standard deviation is S. That's the letter. Oh, no matter how I write it, it looks like the number 5. Does that look a little better?
Yeah. I was just a little confused.
Yeah, S stands for standard deviation. The variance is the standard deviation squared. The variance is referred to as S squared. The variance is also a measure of deviation, but you're not going to see the variance used very often. And so we don't use it in this class. We don't use it other than as the last step before we find the standard deviation.
Okay.
Oh, crap. We're out of time. So I will stop here right now, which is actually where I ended with the other section. I promised you a big Batten formula. We'll look at another example of finding the standard deviation from the table next class, and then we'll start with the big bad formula. Please remember that there is a quiz that you need to take before next class. Is everybody all right if I stop sharing my screen? And I will stop recording.